Hello everyone, welcome to the next video on our YouTube channel. So previously we discussed how Mr. Cell rests in peace via the pathway of necrosis. In this video, we'll discuss another pathway which Mr. Cell could take if things go down south, and this is a little more organized, one that doesn't create a painful death for our dear cell and the one that does not disturb the remaining surroundings. This is apoptosis. So as always, comments, questions and healthy discussions are most welcome and they can be posted down below in the comment section because knowledge shared is wisdom gained. So let's start. So before we begin our discussion, here's a very simple MCQ based on our previous discussion. So I'd like to call this my double-edged sword or DES MCQ of the day. Why is this called DES MCQ? Because it helps you all refresh your memory and it also helps me know if you've all understood, liked or even listened to the previous video. Works both ways, right? Come, let's see what the MCQ is. So, your DES MCQ of the day is, what is the appearance seen in a necrosed tissue under light microscopy? Is it A. Moth-eaten appearance, B. Flea-bitten appearance, C. Swiss cheese appearance, or is it D. Zebra pattern appearance? So you can comment whether it's A, B, C or D down in the comment section below. So moving on to our topic, apoptosis. So, how do you define apoptosis? Apoptosis is defined as the induction of a tightly regulated suicide program where the cells destined to die, they activate intrinsic enzymes that degrade the cell's DNA as well as nuclear and the cytoplasmic proteins. It is a complex definition, but our job is to break it down and make it simpler. So come, let's see how it can be made simpler. In order to simplify the definition previously discussed, we'll go back to the story of our Mr. Cell and use the help of this wonderful diagram from Robin's textbook. So, this is our dear Mr. Cell who has decided that he wants to spend his last moments peacefully. So he undergoes something called as intrinsic enzyme activation, that is activating enzyme from within his system, which will lead to this chromatin becoming very small and dense, which is called as chromatin condensation. There is also the separation of the cell membrane. So whenever the cell membrane separates, it forms something called as membrane bleeds, and that would lead to cellular fragmentation, that is disintegration of the cell's DNA as well as nuclear and cytoplasmic proteins. Now this cellular fragmentation would lead to the formation of apoptotic body. What is apoptotic body? It is nothing but these small parts of the cell membrane which contain nucleus as well as a portion of the cytoplasm, and that is surrounded by the plasma membrane. Now this apoptotic body is then completely eaten up by the cells which are called as macrophages. So this process is called as phagocytosis. Since these apoptotic bodies are completely consumed by the macrophages, inflammation does not occur. So the main features of apoptosis are formation of apoptotic body and phagocytosis, or completely eating of the apoptotic body by these macrophages, which does not elicit any inflammation. As discussed in our previous video, apoptosis can usually occur in physiological state as well as pathological state. To understand this concept better, let us look at some examples for both the states. We will start with the physiological causes of apoptosis. Now the first example is after cells serve their purpose. What do I mean by after serving their purpose? Let's say for example, to eliminate any offending agent, the body undergoes inflammation. Neutrophils are the predominant cells which are activated during inflammation and which eliminate the offending agent. But after their job is done, the neutrophils will also be eliminated. So that usually happens by apoptosis. The second example is self-destructive cells. Let's say for example, you have your lymphocytes, but these lymphocytes, due to some signals within itself, becomes harmful and they become self-reactive T cells. Now these self-reactive T cells will be recognized by the body and they will be eliminated by apoptosis. The third example is embryogenesis. So, the body usually undergoes developmental changes, which is also called as embryogenesis. During development, the body sometimes will have certain extra cells which are called as supernumerary cells. These supernumerary cells will not necessarily be useful to the body. So, if the body recognizes these supernumerary cells, it will eliminate these cells by apoptosis. The fourth example is odd cells. Let's say, for example, a cell is infected by a virus or certain carcinogens which make it a cancer cells. Sometimes the cells will also be transplanted to the body, but they may necessarily not be useful. They could be harmful cells. So if the body recognizes these kind of cells on time, the body will eliminate it via apoptosis. Now let's look at some more examples of physiological causes of apoptosis. The next example is old cells in highly proliferating organs. So what do I mean by highly proliferating organs? There are some organs like the intestinal crypt wherein new cells are continuously regenerated. For that, the old cells need to be eliminated. How does that occur? That usually occurs via apoptosis. The next example is hormonal. Now, there are various organs in our body which are hormone dependent and which usually undergo continuous regeneration and elimination of old cells. Now, that usually occurs via apoptosis. So, for example, if you take the endometrium, there is usually a breakdown of the endometrium because of low estrogen and low progesterone, which will lead to menses formation, and that usually occurs via apoptosis. Because of low estrogen, the ovaries will also undergo something called as atresia or complete shrinkage of the ovaries. During lactation, there will be less oxytocin during weaning. So there will be a reduction in the breast size, and that usually occurs via apoptosis. There is also certain procedures which we all know called castration, which will lead to reduction in or atrophy, reduction of the prostate size, which also occurs via apoptosis. Now let's try to understand how apoptosis works by looking at certain pathological causes. As we all know, our body is capable enough to remove any DNA damage or any offending agent by itself. But sometimes what happens is there are certain external causes like radiation or heat which will irreversibly damage the DNA. So in this case, what happens is there is increased mitochondrial permeability and accumulation of toxic proteins. Now that is usually eliminated by the body via apoptosis. The next example is duct obstruction. Now in organs like pancreas or even in organs like parotid, due to various causes like alcohol and etc., there will be duct obstruction. Now that will also be removed by the body via apoptosis. The third example is something that we saw even in a physiological cause. So for example, the body or the cell is usually infected by viruses like HIV or adenovirus. So either it is directly infected by the virus or the body develops certain immune responses to eliminate the particular virus, but in turn which will be harmful for the body. Now that can be removed via apoptosis. Let us try to understand what are the morphological changes in apoptosis. So this is a very informative light microscopy photo to show how a tissue undergoes apoptosis. There are three very important features: nuclear condensation, cytoplasmic condensation, as well as nuclear fragmentation, which occurs in apoptosis. So we see here that in A and C, the nucleus and the cytoplasm, they appear very dense, they appear very small, they appear very eosinophilic. So this shows nuclear and cytoplasmic condensation. In B, as you can see here, the nucleus has broken apart into small nucleosomes, and this is called as nuclear fragmentation. These are the three most characteristic features of apoptosis. To give you all a clearer picture of what happens during apoptosis, this is an electron microscopy photo. So as you can see here, many cells, they show condensed chromatin, as well as there are fragmented nuclei into nucleosomes. This is a cultured cells photo which is undergoing apoptosis. So as you can see here, cytoplasmic blebs are all formed and these are all apoptotic bodies. So we saw what happens to a tissue when it undergoes apoptosis, and we also saw the morphological changes that are usually seen in apoptosis. But what are the biochemical changes in apoptosis? Come, let's find out. Before trying to understand what are the biochemical changes that usually occur in apoptosis, it is very important to understand what are caspases. Caspase is nothing but they are important markers of apoptosis, and these caspases they need to get activated. What happens when they get activated? They will cleave the protein at the C terminal of the aspartic amino acid, which is why if you shrink that entire definition, it becomes caspases. So this caspase via endonuclease initiates a DNA breakdown into internucleosomal fragments. Now this endonuclease enzyme is what gives a stepladder pattern of the apoptotic tissue in an agarose gel electrophoresis. To understand this better, I will show you a picture in a minute. One thing before I show you the picture, it's very important to remember that apart from caspases, annexin 5 is also an important marker for apoptosis. So as you can see here, because of the endonuclease, there is a stepladder pattern in the tissue indicative of apoptosis. If there is a smear pattern of the tissue, it is indicative of necrosis. What do I mean by smear pattern? Have you all seen a peripheral blood smear? Have you all seen how the blood film is so smooth and so straight? There are absolutely no breaks. Very similar to that, in the agarose gel electrophoresis, if the tissue has undergone necrosis, it will give us a smear like pattern. So till now we have seen how to define apoptosis. We have also seen how an apoptotic tissue looks under the light microscopy, under the electron microscopy, as well as what are the biochemical changes that occur in apoptosis. But isn't it important to understand how actually apoptosis works in our body? Come, let's now understand the final but the most important part of our discussion, the mechanism of apoptosis. So, the entire process of apoptosis can be divided into two phases. One is the initiation phase and the other is the executioner phase. This initiation phase has two more parts to it. One is the intrinsic apoptotic pathway, which is also called mitochondrial pathway, and the other is the extrinsic apoptotic pathway, which is called as death receptor pathway. Phew, so many phases for apoptosis, so many subphases for apoptosis. Isn't it a little confusing? But our job is to make it simpler. So in the next few slides, we will discuss each of these phases in detail. Before talking about the initiation as well as the execution phases in detail, it is very important to understand how is apoptosis regulated as a process. Apoptosis is regulated with the help of a BCL2 family. How does this BCL2 family work? Come, let's understand that with the help of our favorite story time. So let's go. Let's say for example you have a house and this house is called as mitochondria. But beware, this is no ordinary house. Mitochondria is also called as the energy house of the cell because it gives energy to the cell. This mitochondria has two gates. One is the inner mitochondrial membrane, the other is the outer mitochondrial membrane. Between these two gates, there is a magic potion that is running which is called as cytochrome C. This cytochrome C provides energy for all the constituents or all the members inside this house called as mitochondria. But due to some reason, let's say for example, any cellular damage is there or any membrane stress is there, this cytochrome C tends to leak out through the outer mitochondrial membrane. So that would lead to energy deprivation for the members inside the mitochondria, leading to apoptosis. So this entire regulation of whether cytochrome C should be inside or cytochrome C should be leaked out is taken care by the BCL2 family. This BCL2 family is like an organization. There are three major classes of BCL2 family proteins. One which makes sure that the cytochrome C leaks out through the outer gate, which is called as pro-apoptotic proteins, which are BAX and BAC. One which make sure that the cytochrome C does not leak out come what may, and it is contained within the two gates, which are called as anti-apoptotic proteins. Now these anti-apoptotic proteins are BCL2, BCLX, MCL1, and the other one is also called as pro-apoptotic BH3. There is a family called as BH3 proteins which are pro-apoptotic, in which there are proteins called BIM, BID and BAD. They will make sure that this cytochrome C leaks out no matter what. So with this understanding, let us now move on to each of the phases of apoptosis. We have now understood how the BCL2 family gatekeeps or regulates apoptosis. So let's now try to understand how apoptosis works. We'll start with the first part of the initiation phase of apoptosis, which is called as the intrinsic pathway or the mitochondrial pathway. So here is a comparative photo just to show how a viable cell reacts for any cellular stress and how an apoptotic cell reacts for any cellular stress. Say for example, you have a viable cell and there is some cellular stress or some membrane damage that is occurring. But our viable cell will have survival signals, that is growth factors. This will produce anti-apoptotic proteins like for example BCL2, BCLX1 and MCL. What do these anti-apoptotic proteins do? They make sure that our magic potion Mr. Cytochrome C does not get leaked out, come what may, out of the outer mitochondrial membrane. So there is no leakage of cytochrome C. But what happens in an apoptotic cell is already the cell is in its final stages. So whatever cellular stress and membrane damage occurs, there is no survival signals that is generated. So causes like irradiation, etc., cause membrane damage or the DNA damage, and once DNA damage occurs, there is activation of our sensors or the BH3 family. What are our BH3 family proteins? They are the BIM, BID and BAD. And what are they? They are pro-apoptotic proteins. So they will make sure that this BCL2 does not function, and they will activate your pro-apoptotic proteins, which is a back and back channel, and then there will be leakage of cytochrome C through the outer mitochondrial membrane, and there will be activation of caspases. In intrinsic pathway, the caspase which is generated is caspase 9. This caspase 9 is triggered by the release of a protein called as apoptosome. That apoptosome is activated by apoptosis activating factor 1 or APAF1, and that is brought about because of leakage of cytochrome C. So this entire process would lead to apoptosis. We'll now understand the second part of the initiation phase of apoptosis, which is also called as extrinsic pathway or the cytoplasmic pathway. So we have a plasma membrane here in which sits a receptor, which is called as the Fas receptor. This Fas receptor is a member of the TNF family of proteins, and this Fas receptor has a death domain which needs to be activated in order for apoptosis to occur. Now, since I'm calling this a receptor, how do you think this will be activated? This will be activated when a ligand comes and attaches itself. So there is a Fas ligand which comes and attaches itself to the Fas receptor. So once that happens, there is trimerization of the Fas receptor. What do I mean by trimerization? This Fas receptor becomes into 3. That is called as trimerization. So once the trimerization occurs, at the death domain, there will come a protein, an adapter protein, which is called FADD or FAD protein. Now this FAD protein, once it comes and attaches itself to the death domain of the Fas receptor, it will trigger activation of caspase. Now how does this caspase get activated? It gets activated from this procaspase 8. So once this procaspase 8 gets activated into caspase 8, it triggers all the executioner caspases which will trigger apoptosis. Before moving on to the execution phase of apoptosis, it is important to understand that there are certain proteins which can inhibit the intrinsic pathway as well as the extrinsic pathway. So the intrinsic pathway is inhibited by the IAP protein and the extrinsic pathway is inhibited by the FLIP protein which inhibits the caspase 8. So the intrinsic as well as the extrinsic pathway will release certain executioner caspases. These executioner caspases are caspase 3, 6 and 7, and these are the common executioner caspases which are usually involved, and they usually cause apoptosis by DNA degradation with the help of DNases, which is the enzyme for DNA degradation. So I hope you all enjoyed this short video on apoptosis. If you did, please like, share and subscribe, and wish you all a happy learning. See you in the next video.